Howdy, y'all. This is General Gamble, Mark Gamble. Um, Doing another presentation. I had some very interesting thoughts on the wind farms, and there's a lot that is not covered that I thought needed to be flushed out. So uh, this is more or less. I think once you see the edge, like the end of this, you'll understand why I'm so excited. Now this is basically to connect wind towers to the superstructure that you're trying to create outside of the wind tower. And this probably, I wouldn't think it has the best actual characteristics at this point. I'm just trying to show that you have this receiver bolt array which is on the front drawing, and you have the top drawing which shows you the overview of where you would need basically extra reinforcements for something like that, because each buoy in the case of these wind towers would be under tens of thousands of pounds of stress. Okay, so this is going to take and I have later models in this that I basically think you can get it down to not using any metal almost, but I'll show you. Okay, and this is more about any sort of system that you would create to distribute the weight of these counter tensions from the buoys to the wind farm towers. They're going to need basically a weight distribution through the materials, because the materials themselves are not actually strong enough at the point of contact with the buoys to actually keep themselves from being torn apart. So in a few places, very few places, you're going to need a rigid strength cage in order to distribute the weight back into the buoys from the hinges of these things. This is a really, really primitive idea. I've got better. And ultimately that there might be some sort of hybrid eventually of these types of ideas. Because once I'd gotten going, I had a dream about the last one. Uh, so I decided to add that to this one. Okay, now regardless of whether you have a what system you use, this is more or less way of saying that there's a way of distributing in this model metal cable arrays, but the other models that I have later don't even use metal cable arrays. But either way, you'll probably need, if you're going to use such loose materials like polystyrene filling, a layer that has weight distribution quality. And in this one it's waste wood. If you watch the earlier videos, I explained that really the goal is more or less to turn the entire system into waste product. From waste product comes wind tower foundations. And the charm of this is that if you're using a buoy system like this, you can run the power cable in the buoy system, and you wouldn't have to worry about basically running underground or underwater cables, and you'd have a lot less mooring costs. But that's covered in earlier videos. If you're not familiar with it, then I suggest you watch the earlier videos. Now this is dealing with the idea of basically the use of floating buoys that are not connected as rigidly in the course that that shock in the system, as is with a muffler, would go to the part that has the most open channel to that shock. And the only way of making a more open channel is to essentially have a rigid connection to a tensile strength connection, where the tensile strength can move and goes in directions the rigid strength can't. And so this actually comes up later, but for right now, it's basically only that the movements of these buoys can be used to absorb shock in the system from a static standpoint. And in this, it also reduces, instead of increases, the amount of weight that you have to carry in basically a buoyancy system, which is what this all is. Think of it like the wind farms are hanging from a chandelier, right? Instead of posted back from a set of wires. And that's the way that this basically is supposed to work, right? And the few fixed in that system, the few fixed points in that system will create basically a harmony where it'll stay in the same place and hopefully have all of the shock go into the buoys instead of the wind towers from the waves and regular wave action. And therefore, you have to use many fewer cable stanchioning members. Now, these are kind of an experiment, or this idea is kind of an experiment. It's the same idea as the earlier one with the shock buoys that would go left and right, or forward and back dimensionally in space, depending on where it's the opposite of static. But anyways, depending on which way that the force moved it, it had very high freedom of motion. Well, all of these membranes have a high freedom of motion, right? And I'm sort of doing this without a script or anything. Usually I would script all the information, but there's a lot of material to cover, so I figured that I would just kind of take it on the fly. Now this is basically the same system as the other shock buoy system. Only that the weight of the size of the buoys, which are pretty much everything in yellow, would be like something that could float. Really like thinking polystyrene materials and stuff like that. Although I don't think this is optimal anymore. Although it's a really interesting thought experiment. If you could get basically the weight of all of the counterweight to be movable, right? From a tensile strength, then all of those would move counter to the top part, and their momentum would get rocked first, basically. And so it'd be a way of killing shock. But I think part of it is, you know, if you have these things at all close to the wave structures that are a little further up, then they're just going to cause more resistance, which is, in and of itself, it would be its own problem. So, resistance is something they're messing with the High Wind project, incidentally. So, that they're trying, like, to, cut down, like, I'd read in their papers, the actual resistance to waves, like make the designs more hydrodynamic. And I don't know that this is very hydrodynamic, but it's a cool idea. You just have tons of these little plate things, and they would just rock around like kelp. Now this is a completely different sort of an idea, and I don't know if it would work, but I think it probably would. And I call it a spring jack, basically, or a spring jacket. And what it is you've made like a key to stick the tower on, right? And that goes all the way through a tube that is the actual tube that holds all of the weight and buoyancy, right? Do you follow me? I hope. Now, I don't have the pictures, and I have in a later picture how this would connect to like a floating wind farm system, but this is more or less like kind of how the shock transfer would work. And on the page with the green and the red, or the side with the green and the red, basically the red is supposed to show you where the actual input for energy goes to, right? Like direct input energy goes into red plate. Green is the shape of the transfer energy for the movement. So therefore, if you got a massive push left, and you'll notice these springs, and this is why it's a spring jacket. The springs really are only supposed to be part of the equation for this particular idea. It's like you have you have to have, and I don't have it in here, but I think really pneumatics would probably be best. Something that allowed it to move on a degree directional axis still as a tower slightly, like less than a degree, right? But then all of that momentum, which is still thousands of tons, you don't really want it to keep going that way, or it'll just capsize itself unless you have a counterweight at the bottom. So I have an idea for this too, and I get into this later in this. So it's pretty funny though. Okay, well, all of that weight at the bottom either has to be tethered down to keep it that way, or it has to have a lower or a weight way below, so that all of the, like a ship all with a ballast, well, they're both called ballasts, but the metal part that you sometimes make out of lead and holds the thing down in shipbuilding, and most modern shipbuilding it's used with water. Well, that thing, that and the keel fucking weighs millions of tons, because that's all grafters metal. Anyways, that weight keeps the ship from capsizing. It keeps the high wind design from capsizing. The weight is like way below the actual capsize point, and therefore balancing point of the whole system. Now, I don't know if that's necessary, and I think maybe with a buoy system, if you did this correctly, with this type of shock thing, maybe the weight overhead could get to be enough, but in this one it's pictured with a cable system pulling it down. But that only like a single one, because all you need is to make the tower the thing that is a fixed point, and the buoys are the unfixed point. So they're waving around like a wacky, incredible, flailing, waving arm man, and the central jacket is letting it do that. It's just kind of bouncing around, and you know, the thousands and thousands of tons that is being distributed into pneumatics. But you know, the 50 tons of like shock going in any particular direction, the buoys, right? And I'm not sure, even though this kind of has a scale, what the scale would have to be. As I'd said, this is more of a thing that has been developing, and it is not actually the particular thing that I had dreamed of. But to give you a better idea, based on the previous articles of what this could have the potential of, I believe that if you have, like, over, once you get to a certain weight distribution level, basically, you no longer need metal cables for their material strength to hold this in place in the sea. And that, in and of itself, is this huge secret boon, right? Is that if the metal cables aren't needed, then what are you using? You're using, like, the best types of poly rope, right? And poly rope on itself actually does float. So as part of a buoy system, if you had, like, the right type of rope setup and everything, all of the forces were combined in the right way, which is part of what this page is about, then you wouldn't really necessarily need cable, right? And that's what this is, this first top screen. Now this is more or less, it's not exactly what I think one of these wind farms would look like, but it's very close. And what you see is this ribbing material, right, is made of just basically very large arrays of netting on the outside, probably plastic netting, and weave together a bunch of, like, Coke bottle, you know, holding things. Plastic bag layer, which is more or less to, like, reduce the amount of, like, water that could leak through it. If you could get it to zero, but I'm guessing everything you're going to want, everything in the system you're going to want, basically, to be somewhat watertight on its own anyways. A big, like, probably about 99% of the actual material in this will be crushed and shredded polystyrene. The idea is to basically be able to make it with, like, a minimal of really manufactured, or, well, needfully manufactured materials, almost like, you know, cars are almost 100%, almost 100% made out of recycled materials in most places nowadays. So it would not be surprising that such a big infrastructure investment, you would want to use recycled materials. Now, the real special sauce with this type of a system is that you have to connect these long floating buoys together as well. And I realized this, and the fact of the matter is, this could also be like an application where you just use a big stupid wooden, maybe like a wooden plastic coated rod or something. But what it does, what doing that does, and this is the last drawing, is makes it so that the counter, what do they call them? It's basically like the bridge, but in reverse. So I don't know what you would really call it. I believe they call it a carpentry or something, but it's basically where a tensile force is suspended between two mechanical forces. And that tensile force is then also, like, reacting to gravity at the same time. Only in this case, it's in reverse, because all of the buoys want to go up and therefore make this arching pattern upward, but that's also charged with the weight of gravity versus whatever it's holding. Now, basically, at the end of the day, you can do anything with materials. So this is a ridiculous question as to whether the things can be, do we have the materials? Are they strong enough, and what is the cost? We know the wind towers, you can make them, but what is the cost? How much do they, like, cost to make? And in some ways this would increase the cost, but I think this would probably be a really cool idea, actually. And that is to take the earlier shock buoy systems, connect them to such a jacket, shock jacket, and instead of transferring the shock into the buoys, which is one of the problems with this whole thing, is if you make all of these floating buoys for really gross movements, unless it's like directly statically connected, which would be expensive, you would need something that could take that type of a shock on a gross, immediate static movement sort of a way. And if you put the original shock buoys, because remember, all of these are floating. All of these counterlever basically the weight of what you're already putting in the water, which is in the 36,000 ton or 39,000 ton range, or pound range. It's bigger than that. I think measured out it because it's 1,300 metric tons. And so, anyways, enough weight. And I've done the calculations so that basically you need to suspend like 40, I think it's 42,000 square meters. That's times 3 of that, or shit, bigger than that, in square feet of polystyrene, okay? And basically, that in order to do this, you should take any floating system you can take. And the original idea of the shock buoy system is to take a rather large amount of weight, like in the tons of counterweight, and have that counter suspended. Like up in the water rather than down in a way. But and also I'd like to note that that's one flaw that seems to be in the Hywind system, is if you tie the buoys right under, or if they're directly mechanically tied to the tower, right, rather than going through any sort of shock system, which I know they have the original Hywind had that water ballast thing going on, which I thought was really cool. Then all of that shock is still going to go like directly up through this huge lever in the case of your tower. And it seems like a huge weakness to build into your system, and maybe why you have such a problem with vibration that you're looking into. Now, if you had a system that looked a lot like the one I was showing you, this is sort of how it would connect. And granted, you'd want basically to put as much cheapness into this as you could, I would imagine, right? Like you want to basically build it all out of polystyrene and polytangent rope, I would imagine. And not because those materials are also, like, if you put them in the correct format, chemically inert to the ocean. And so, as we learned from ecology, there's nothing better surviving in the ocean than these cheap plastics we make. If you format them right, and you protect them from harm in some way mechanically. I mean, many of the ones that we have are already somewhat mechanically protected. That's why they last so long. They're formed to be kind of mechanically strong. Then you can have something that lasts for a really, really, really long time. But I'd still like to mention that I don't know. It's just my personal belief. I haven't really been able to look into it. But it just seems like anything would be better than these big front-facing fan-type designs that have been the consideration, like an egg beater design or a big sail or something like that. That just seems like it would work so much better, because you could put the weight at a sea level almost for the generator and the nacelle and everything that really is going to be very heavy. you know, and you really, you know, because the weight's at the end of the cantilever. You want the weight to be in the center where the action is, where the wave motion is. This is just an idea. So you know, and I guess this is a good illustration of it. Almost all of this extra mechanical stuff I'm putting in here, uh, when I do the measurements, it's just that if you weren't to have the extra points of control, the nature of the tower would make it fall over really quickly. Um, but, you know, this is just my thoughts. Maybe I could be very ignorant, and admittedly I'm somewhat of a neophyte in this whole field, even though I love the study of power generation. It's what I do, really, as an inventor. Although I've done many other things, so maybe I'm missing some aspect of why you need that big long tower at the end of a stick. And this is what I always wondered about this thing. Now, you got your recent underwater turbine that you use for generating tidal waves. I know this because I study like almost anything Scotland or any alternative energy group would put out. And you've got the wind tower on top. And you need this huge counterweight anyways for the current high wind model, and it works very efficiently. Why wouldn't you then just double weight it instead of having some dumb weight at the bottom? Have like a one of those water turbines, which would probably be almost the same exact weight as the wind tower on top, and therefore be like a double ballasting system. And, you know, beyond that, I mean, of course, you could use an outside ballast system. I think it's a great idea. I mean, this is kind of what I'm pushing is, you know, don't transfer your power through the ground. You know, just use a ballast system to float it all around. And but, you know, why these haven't been combined, the tidal generator and the wind tower, I have no clue. So it's just food for thought. This has been General Gamble. I think this is the last slide, so I'm signing out. There's ways of contacting me in the information if you follow that. Pretty soon I'm going to have a meetup, and I'm going to have access to AutoCAD again. That'll be nice. Alright, much love to you, my inventors. Bye.